Welcome to Series 8 of the Animated Maths for All video series. We're here to learn, grow, and excel in mathematics together. Our students from Animath International School are embarking on an exciting educational excursion. Their destination is the magnificent pyramids, and they are traveling by helicopter for a fantastic view. Here is an aerial view of the famous pyramids. What a spectacular sight! The students are amazed by the number and size of the pyramids, sparking ideas for their own beach constructions. Back at the beach, the students start building different shapes in the sand. The asymmetrical group constructs 3 sand pyramids. This sparks a question about how to calculate their volume. It's important to remember that the height of the base is different from the height of the prism itself. Here we see a sand prism with a trapezium base, and we can identify the height of the trapezium and the height of the prism. The traditional volume formula, base area times height, is not for these pyramids because they have slanting sides. The prism we are focused on has all vertical sides, unlike the pyramids, making the formula applicable. We need to find the volume of this triangular prism. The base is the cross-section that remains constant through the length. We can visualize the triangle as the base and the length as the height, or simply imagine it without physically turning the prism. We calculate the base area of the triangle and then multiply it by the prism's length to find the total volume, which is 960 cubic centimeters. Note that a dot represents the multiplication symbol in these videos. Here is an example of a prism with a trapezoidal cross-section. We have its dimensions for future calculations. First, we use the formula volume equals base area times length. After calculating the area of the trapezoidal base and multiplying by the length, we get a volume of 6,270,000 cubic centimeters, or 6.27 cubic meters. To convert cubic centimeters to cubic meters, we divide by 1 million, since 1 cubic meter is 100 centimeters by 100 centimeters by 100 centimeters. This confirms the final result of 6.27 cubic meters. Next, let's find the volume of this toy house. We can treat it as a composite solid, specifically a triangular prism on top of a cuboid. We can calculate the volume by either adding the volumes of the cuboid and the triangular prism, or by finding the total base area of the composite figure and multiplying it by the height. Base of the triangle, 8.5 centimeters, height is 10 centimeters, and prism length is 9 centimeters. For the cuboid, length 9 centimeters, breadth 8.5 centimeters, and height 8 centimeters. Using the individual component method, we calculate the volume of the triangular prism to be 382.5 cubic centimeters and the cuboid volume to be 612 cubic centimeters. The total volume is 994.5 cubic centimeters. Using the composite prism method, we find the total base area is 110.5 square centimeters. Multiplying this by the length of 9 centimeters gives the same total volume of 994.5 cubic centimeters. Now, let's find the volume of this slightly more complex composite solid built by the students. We identify this as another composite solid with parts labeled A and B. Let's find the volume of this composite solid now. First, let's find the volume of part A, which is a trapezoidal prism with a base. The students decide to take the picture, go to classroom, and calculate the volume. Let us first calculate the volume of part A. First, let us calculate the base area of the prism. The trapezium has parallel sides 18 centimeters and 12 centimeters, and the height is 20 centimeters. Using the trapezium area formula for part A, base area equals 1/2 times 18 plus 12 times 20, giving 300 square centimeters. Volume equals 300 times 12, which is 3,600 cubic centimeters. For part B, the base area is 12 centimeters plus 6 centimeters times 10 centimeters, which equals 180 centimeters. Half of 180 centimeters is 90, and 90 square centimeters. Volume of part B is 90 times 12 equals 1,080 cubic centimeters. When we add the volume of part A, which is 3,600 cubic centimeters, and part B, which is 1,080 cubic centimeters, we get 4,680 cubic centimeters. So volume of the composite solid is 4,680 cubic centimeters. Here is an image showing the trapezoidal prism. The base is the cross-section that remains consistent throughout the shape. Avoid misconceptions. The base of the prism is the consistent cross-section, not just the side resting on the ground. The height is the distance between the two identical bases. The lady here is wondering what would be the volume of this container. We are interested in the volume of this container. We need to identify the area of the base and multiply it by the length or height of the prism. Let us divide the trapezoidal base into two parts, A and B. We need to find the area of both parts to get the total base area. We have divided the base in such a way that part A is a trapezium and part B is a rectangle. There are other ways to divide the base too. Discuss with your friends. Let's assign the given dimensions to the base. We have 50 centimeters, 35 centimeters, 40 centimeters, and 45 centimeters for the trapezoidal side. The length is 30 centimeters. The base is made up of trapezium A and triangle B. We need to calculate the area of both shapes. Let us calculate the area of the trapezium A, which is half times the sum of the parallel sides times the height of the trapezium. Now let us calculate the area of the triangle, whose base is 40 centimeters and height is 30 centimeters. Half times base times height gives the area of the triangle. Total area of the trapezium and triangle is 1,487.5 centimeters squared and 600 centimeters squared, which is 2,087.5 centimeters squared. Base area, 2,087.5, times the height 45, gives the volume of the container as 93,937.5 cubic centimeters. The calculation for the total base area, which is A plus B, is 2,087.5 square centimeters. The height, or length of the prism, is 45 centimeters. Substituting the values into the formula, the total volume is 93,937.5 cubic centimeters. This is the final result for the trapezoidal box.